Hi everyone, welcome to Last Minute Maths, and in this video we're going to be looking at simultaneous equations. Now, before I jump in, I just want to say there are, as you can see here, three types, all right? Three types of simultaneous equations. So if you're revising or in the process of revising your GCSE material, etc., then feel free to skip forward, jump to whichever type of simultaneous equations that maybe you need more help on or you're looking for an explanation for. You don't necessarily have to watch the whole video. I'm going to put timestamps, little chapter times in the description. So just click on that and go to whichever one that you think you need. All right. And as always, your comments, suggestions, questions are always welcome. So don't forget to subscribe and hit the like button and leave any thoughts and comments you have down below. Right, let's go into this. As I'm saying earlier, three types of equations, all right? And what are simultaneous equations? Okay. Effectively, you're going to get as far as GCSE and to some extent A-level is concerned, two equations in X and Y, all right, where the same values of X and Y work simultaneously at the same time. That means for both equations, hence simultaneous equations. All right, fairly obvious. Best way to learn this, I think, is just to illustrate a couple of examples. So of the three types, the first one, all right, type A, and this is not through from the spec or from a textbook like type A, B, and C. That's just my own way of labeling the three different types of questions you're likely to see. So that's my system. Don't expect to see that anywhere else, etc. And you know, if you want to call it something else, please do. All right. So type A are two linear equations. All right. Exactly what that says. Now, if I were to give you, I don't know, something like an equation like this, all right, we can actually turn that into y equals 3 minus x. So you can see how that is a straight line equation. All right, of the form y equals mx plus c. All right, so that means any linear equation you can actually convert into the equation of a straight line. Okay, so two linear equations are effectively two straight lines, and any point where they intersect will give you values of x and y that are true for both equations. So this point that I've got here in the middle here, all right, on the lines, that point, that set of coordinates, x and y, sit on both the lines. So therefore, that particular value of x and that particular value of y, all right, will make both equations true at the same time. All right, so that's the principle of the rest of the video in terms of all simultaneous equations. And we'll just go straight into an example and illustrate how to go about finding this. So I've taken perhaps a less than simple example just to hopefully give you options in how you solve them. We've got equation 1, and I would always recommend you label your equations 1 and 2 on the side so you know what you're working with. All right. So the second one, well, let me finish the first one first. 3x plus 2y equals 16. And then the second one, 2x plus y equals 9. All right. So we're looking for a value of x and a value of y that makes both equations true at the same time. All right. Now, in terms of solving it, you've got option of two different methods. One is called the elimination and the other a substitution method. All right. Now, the elimination method, that only works, only for two linear equations. You cannot use that for any other type, all right, as you'll see below. All right, so please watch out for that. And the substitution method for all types. Okay, right. So what do? Sorry, don't mean to move the screen around so much. So we're going to start by picking one of the variables, either x or y. All right. So step by step, very simply, pick a variable. In this case, I've decided to eliminate y. All right. I'm going to get rid of the y from my equations. So in order to eliminate the y, I need to make the coefficients of the y the same. Look at my original equation 1 and equation 2. I've got 2y in one of them, and I've got, well, you call it a single, like a 1y, if you like, right? So I've got a 2 and a 1. I need to make those coefficients the same, all right? So having picked y as the one that I want to eliminate, I then want to make the coefficients the same. Best way to do this is to take equation 2 and times it by 2. So I end up with 4x, so 2 times 2x, plus 2 times y equals 2 times 9. All right, so that's 18. Okay, 4x plus 2y equals 18. And that now gives me 2y in my equation 2 and 2y in my equation 1. All right. So what I then do is subtract equation 1 from equation 2. All right. So nothing too technical in all this. Simply that you've now got 2y in both equations. Take one equation away from the other. It's as simple as that. All right. So if I take equation 1 away from equation 2, 4x minus 3x is x. 2y minus 2y. Remember to apply the minus to whatever's inside the bracket. 2y minus 2y, 0, and 18 minus 6. You know what? I've just realized something. I should really put that bracket all the way around here. All right, that's my mistake. Right, so what we end up with is x plus 0 equals 2. So x equals 2. All right. Hopefully I haven't confused you too much. All right. Now that we know that x equals 2, put that back into the first equation, equation 1. All right. Have I done it in equation 1 or have I done it in equation 2? Equation 2. All right. So in this one, we've got 2 times x plus y equals 9. So all I'm doing is replacing the value of x. 2x plus y, so 2 times 2 plus y equals 9. And fairly obvious, y equals 5. All right. So the way we present the solution is as a set of coordinates 2, 5. All right. Remember that the value of x and y that satisfy both equations is actually a point of intersection between two lines or two curves, if you like. And so we can actually write it as coordinates. Okay, the alternative method, all right, that was the elimination method. The alternative method is substitution, all right, which will become more important later on. So in this case, what we're doing, we're starting with equation 2, rearranging it to make y the subject, because I've decided I want to get rid of y, if you remember. So y equals 9 minus 2x. I'm now going to substitute that in. So I'm replacing y in equation 1. All right. So where there was a y, I replace it with 9 minus 2x. So I get 3x plus 2 times, brackets 9 minus 2x, equals 16. All right. So expand the brackets, you get 18 minus 4x, and tidying that all up, collecting like terms, 3x minus 4x, you get a minus x, and you have the 18. So 18 minus x equals 16, minus x equals minus 2, and therefore x equals 2, as we had before. And again, putting it back into equation 2, you've got y equals 9 minus 2 times 2, right? So y equals 5. So we get exactly the same solution that we had before. Let's write it like that. And presenting it exactly in the same way. So you can see both methods offer up exactly the same solutions. There is no right or wrong to it. It's whichever one suits the particular question better. And that's for for you to decide in the exam itself. I'll give one other example on this particular one, just to show where the elimination method does actually work better. Okay, if we have an example like this, where equation 1, you have 3x minus 2y equals 8, all right, so that one there, and equation 2, you've got 5x minus 3y equals 14. Now, if I were to try the substitution method in this, and I just want to say why perhaps it's not a good idea to, is let's say for equation 1, we rearrange it to get x on its own, all right? So we're going to get 3x equals 2y plus 8, x equals 2/3 y plus 8 over 3. All right, you don't really want to be subbing that into other equations or whatever. It's not pretty, all right? And in maths, we don't like ugly solutions and ugly methods, all right? So in this particular case, you are, the best way to do this is use the elimination method. And for two linear equations, whatever the coefficients of the x's and y's are, it doesn't matter. The elimination method is probably the best way to do it. All right. Now, in this particular case, I'm going to choose to get rid of x. All right. So I want to make the x's, I've got a 3x there, and I've got a 5x there, and I want to make them the same. So lowest common multiple, in this case, 15, all right? So I want to turn them both into 15. The best way to do it is look at times number 1, equation number 1 by 5, and times all of equation number 2 by 3. Now, do remember, you've got to multiply all the terms by whatever multiple that you're thinking of, all right? So when I take equation 1 and I multiply by 5, I get 15x minus 10y equals 40, all right? And then equation 2 times by 3 gives me 15x minus 9y equals 42, all right? So I've now got my x's with the same coefficient, 15. All right. So I've got 15x and 15x. So if I minus one of those equations from the other, I will eliminate the x's. So I've chosen to go ahead and just subtract it as it is. 15x minus 15x, 0, that's fine. Now, minus 10y minus 9y is plus 9y. I end up with minus y. And 40 minus 42 is minus 2. So y equals 2, all right? And I'm going to then use that in equation 1. So 3x minus 2 times y equals 2. So minus 2 times 2, minus 4 equals 8. So let me just tell you where that came from. So 3x equals 12, all right? 3x equals 12, x equals 4. So my solution in the end is 4, 2. All right, those are the coordinates. Right, hope that's okay there. And then I've got type B, all right? And in this case, you've got one linear and one quadratic, all right? And in this example that I'm going to show you in a moment, look at the diagram here, okay? You've got a straight line cutting the quadratic, and you're going to have usually two solutions. There are 2 points where a straight line could cut a parabolic, a quadratic graph. And one exception to that, I could have something that is a tangent. Oops, let me undo that. Something that is a tangent along there. And you could, if it's a strange question that they decide to set, you could end up with just one solution. But that is more unusual as far as GCSE questions are concerned. All right. So usually two solutions. So you're going to get x1, right? That's a 1, not a comma. y1 and x2, y2. All right. So two possible points and two possible solutions. Let's look at an example just to clarify this. So again, I've got my equation 1, x minus y equals 4. So that's the equation of a straight line. And the second equation, equation 2, x squared plus y equals 2. All right, so that is a quadratic. Okay, now I'm going to use the substitution method because that's the only one that's going to work. Because we do not have x's in both equations, you've got an x in one and x squared in the other, you cannot subtract and multiply and get rid of them. It's not convenient. Can be done, but not convenient. So use the substitution method. Always use the linear equation and rearrange for whichever variable you prefer. You could choose to go y equals x minus 4 perhaps. It's up to you. It doesn't matter which way around you do it. I've chosen to go x equals y plus 4. All right. And then we're going to replace x in the second equation. So where we see an x, we replace it with the value y plus 4. So the second equation becomes y plus 4 all squared plus y equals 2. All right, so you can see that. Expand the brackets and you get y squared plus 8y plus 16 plus the y we had originally equals 2. All right, rearrange, collect like terms, and you end up with a quadratic in y. All right. In this particular example, it turns out we can actually factorize very easily, and that can be factorized into, as you can see, y plus 7 times y plus 2 equals 0. And the solutions we get from that are y equals minus 7 and minus 2. From there, we come to when y equals minus 7, if we put that into equation 1, where x is y plus 4, then we get an x solution of minus 3. And then when y equals minus 2, we get an x solution of 2. All right? So these are in pairs. You've got to write them in pairs like that. And watch out. This is y, that's x. When you write it out in coordinate pairs, you've got to get the right number first. So that's your x, that's your y, and that's your x, and that's your y. So the solutions are minus 3 minus 7, and 2 and minus 2. All right. So make sure you look back and you write them in the right order. Because we eliminated x to begin with, Therefore, we're going to get the y value first and then the x, etc. All right. Okay. Last one. Okay. Type 3 and C in my case. And this one is one linear plus one circle equation. All right. Again, you can see there are going to be potentially 2 points of intersection. Again, usually 2 solutions. Sometimes one solution if they use a tangent. If line is a tangent. So again, as I was showing you earlier on, where it just touches once there. All right. So that could be a tangent. Bit unusual in GCSE, but they could do it, so you need to watch out for that. All right. So again, to illustrate this one with an example, let's take equation 1 here. X plus y equals 3. And the equation of a circle, x squared plus y squared equals 25. Remember, equation of a circle centered on the origin equals that. X squared plus y squared equals r squared. And I will be doing a video on that in the very near future, explaining circle equations, etc. So that's something to watch out for. Okay, we're going to use equation 1 and rearrange it to give us y equals 3 minus x. All right, and then we're going to replace y in equation 2. And that's going to give us x squared that we had. And remember, there's a y squared there. So x squared plus brackets 3 minus x all squared equals 25. So expand the bracket out, and we get 9 minus 6x plus x squared. All right, tidying all that up, and again, collecting like terms, etc. 2x squared minus 6x minus 16. And that comes up with a quadratic in x, x squared minus 3x minus 8 equals 0. All right, and this one does not factorize. So there's no pretty integer numbers for this one. In your exam, probably the easiest way and the quickest method, so as not to waste time, is use the quadratic formula. All right, and put those values in your calculator, and you will get x equals 4.7 and minus 1.7. All right, when x equals 4.7, put it into the linear equation we had, y equals 3 minus x, and you'll get y equals minus 1.7. So that's your first pair of solutions. And the second one, when x equals minus 1.7, you get a solution for y of 4.7. All right, so that's your second pair. So here are your two sets of coordinates, 4.7 minus 1.7 and minus 1.7, 4.7. All right, bit of a mouthful, but there you go. So that basically is 3 types of simultaneous equations that could come up in a GCSE 1. In recent years, it's been sort of more common to have the type C or type B, as I've labeled it. All right, so quadratic, line and a quadratic, or indeed a line and a circle. All right, those have been the most common ones. And to watch out for, if any of you are doing the additional maths, then there's one type that they could do, just in case, and that is actually to have, let me see if I can get a circle in there. Yeah, okay, that'll do. And actually have a circle and a quadratic. Sorry, that's a terrible quadratic, but it'll do for now, right? So you could have quadratic, oops, bear with me. and circle. Okay, that is about as nasty as it could get. And the way to do it, I'm just going to show very quickly what it might look like. Equals a number, I don't know, n, and then you've got x squared plus y squared equals, I don't know, your r, whatever it might be. And what you can do is use the quadratic equation and say y equals n minus y squared, for example, x squared, for example, and put that into the second quadratic. But again, this is something that you'll only see if it comes up with special extra information in the question. All right, not easy and only to be seen in additional maths. Okay, I'm putting that in at the end of the video. Not everybody needs to know that at all. All right. All right, thank you for watching. If you have any questions, any comments, any suggestions, or if there's anything that I've confused you with, then please do leave it in the comments and I will happily reply to that. And if there are any other subjects and topics that you want to see, again, put your suggestions in the comments. And do subscribe and like and share with others who are revising. Thanks for watching.